Exercise and intermittent fasting, they also stimulate mitophagy. This is well known. Caloric restriction, typically 20% reduction in calories is well known in different species to trigger mitophagy. Pomegranate has hundreds and thousands of bioactive compounds. Different forms of exercise regimens, aerobic and resistance, are known to stimulate mitophagy.
Dr. Singh is currently the Chief Medical Officer at Timeline, which develops advanced nutritional and skincare products targeting improvements in mitochondrial and cellular health. With an MD in internal medicine and a PhD in immunology, his experience includes work for top consumer health companies, including Nestle Health Science, startup companies including Timeline and Amazentis. He's authored more than 40 articles for top science journals, been awarded 15 plus patents, and designed and led 15 plus randomized clinical trials. His research over the past decade on the postbiotic Urolithin A and its health benefits has led to the launch of multiple consumer products.
I firmly believe there's three pillars of good health. One is what you eat and how much you eat. Second is exercise. And third is really...
Hi, my name is Chris Burris. I'm a longevity expert and the chief scientist at a lab focused on a longevity molecule. My primary focus is to help people live longer and better lives with science. Make sure to subscribe and share so you and your friends can live longer and better. Well, actually, so you and your friends can live beyond the norms.
Welcome to our next talk on the Uncovering the Secrets to Longevity Live Beyond the Norms Health Summit. Your mitochondria is the powerhouse of every cell in your body, well, except your red blood cells. In fact, each of the trillion cells in your body has between 50 and 5,000 mitochondria in them. To say that mitochondria are important, is to not consider that without mitochondria, we would not be alive. But with so many mitochondria in our body, what do we do when those mitochondria age, become unstable, or just stop being useful? Our next speaker is going to talk about mitochondrial health and its impact on longevity. Our next speaker is Dr. Singh is currently the Chief Medical Officer at Timeline, which develops advanced nutritional and skincare products targeting improvements in mitochondrial and cellular health. With an MD in internal medicine and a PhD in immunology, his experience includes work for top consumer health companies, including Nestle Health Science, startup companies including Timeline and Amazentis. He's authored more than 40 articles for top science journals, been awarded 15 plus patents, and designed and led 15 plus randomized clinical trials. His research over the past decade on the postbiotic Urolithin A and its health benefits has led to the launch of multiple consumer products. Dr. Singh, thank you for joining us today.
Pleasure's mine, Chris. Thanks for having me.
That's quite a lot of accolades there. I'm excited to be connected with you and to jump into this discussion. So before we dive in, how did you come to study? How did you target medicine? And how did you ultimately become an expert in mitochondria and longevity?
Sure. So I'm a trained internal medicine physician. I started my medical career in India, then moved to the States, and I was seeing a lot of COPD patients and a lot of older populations that had issues with their immune system in aging. And so I convinced myself to train in immunology, studying really the immune system as we age. And the more I studied the immune system, the more all roads pointed to the poor mitochondrial and poor cellular health of these immune cells. And so, that's sort of how I got into mitochondrial health through my interest in immunology and aging.
And was there anything in particular, you're practicing medicine and then you're noticing this deficiency, how did it all ultimately kind of end up in the mitochondria, right? Because I think there's a lot of, you could have ended up in the gut biome, right? There's a lot of, what kind of triggered mitochondria?
Yeah, so, two ways why I ended up in mitochondrial and longevity area. One, modern medicine, was really treating the symptomatology of a lot of these people with the chronic ailments during the aging. And so we had all these drugs that can alleviate the symptoms towards the end, but there wasn't really much early on when, the whole problems are starting or you're laying the foundation of all the problems. And so I got interested in sort of natural compounds that would hit certain pathways that could impact aging. And then the more I studied at that point, these natural molecules, probiotics, prebiotics, postbiotics, all things kind of led to an immune stimulation via the mitochondria. So this was a field now that we call it immune metabolism. And so really depending on the mitochondrial health of the immune cells would dictate the immune aging pathways. And so I worked a long time for consumer health companies that you mentioned, but then I got interested 10 years back in this molecule, Urolithin A, that was really hitting on mitochondria. And so, yeah, it's 10 years of research and really deep dive into mitochondrial medicine.
And I guess with urolithin A being a postbiotic, you did actually end up in the gut biome.
Again, the chronic inflammation, if you have heard of the hallmarks of aging, and we may get into it, there's 3 new ones. And when the 3 new ones came out, it was for me the aha moment because they connect really my last 20 years of research, which is chronic inflammation, gut microbiome dysfunction, and mitophagy. So they're all linked to each other very closely.
And so those are the 3 hallmarks of aging. What are those kind of, if you could go one by one, like what impact do they have on lifespan and or health span?
So traditionally let's say about 10 years back, the classical 9 hallmarks of aging were described. These are all biological pathways that sort of slow with aging, right? So if we go one by one, they're linked to poor nutrient sensing. So you're eating the same nutrients, but you're not absorbing them, and that's something that happens with aging. Then you have stem cell exhaustion. Now this is very well known. A lot of people know this with aging. Then there's telomere attrition. So again, your genome is becoming more unstable. You get a lot of protein deposits happening in your muscle and your brain, and this leads to things like Alzheimer's disease. So again, you're basically all your cellular machinery. These are things. The 3 ones that I talked about are the 3 new ones that have been added. So now instead of 9, there are total 12 pathways. And the 3 new ones, how they kind of link to each other, I think all these hallmarks of aging have a central foundation pillar, and that is mitochondrial dysfunction. That can explain all these hallmarks of aging, whether it's inflammation, whether it's gut microbiome dysfunction, whether it's poor crosstalk between cellular organelles, or even the nutrient deregulation. So I think mitochondria, and a lot of these hallmarks of aging are not amenable to being changed by the interventions, right? There's a stem cell exhaustion. Yes, we were hearing a lot about stem cells being targeted. Telomere attrition, not so much. But mitochondria, we know we can hit mitochondria and improve them with aging. And so that's why, to me, these hallmarks of aging make so much sense to tackle during longevity.
It's clear that the mitochondria is really important. I think it's got mitochondria, and our understanding of mitochondria is very, very interesting. Like what are mitochondria? What is their kind of exact role in our system?
Sure. I mean, you set it up by saying that mitochondria are called the energy powerhouses. Now, think of mitochondria as the battery of your Tesla car, right? So these are cellular organelles. These are providing the currency of energy that we need to get up from our beds and move around, or think clearly, or after exercise recover. So these are like the batteries in our cells that sort of keep us going, keep us, when we say, oh, do we have fuel left in the tank at the end of the day? That's what we are talking about. This is mitochondria 101.
It's believed that they're separate, that there was at some point cells combined. Talk a little bit about that if you can.
Yeah, so mitochondria evolutionary are thought to be these ancient sort of bacterial origin that sort of developed ancient bacteria that developed a symbiotic relationship during the evolution of the, let's say, the human cell. And by sort of getting inside the human cell, they provide the human cell the energy, but then they take the nutrients from whatever we are eating in terms of from our cellular supply. And so that became sort of the evolutionary link to mitochondria and even the gut microbiome and our cells. So I call it this 3-way axis where the mitochondria sort of our microbiome and what we eat through our sort of nutrition really impacts and plays a very consorted it's really like a orchestra.
It's a pretty interesting symbiotic relationship, right? Where you've got this separate, and my understanding is it's got a separate DNA, right? That comes from your mother's side.
From the mother, yeah. So the mitochondria DNA is separate from our let's say, genetic DNA. All our cells have nuclear DNA, which is basically being transcribed by genetics, but the mitochondrial DNA comes directly from the mothers. And so a lot of mitochondrial disorders are passed from the mother's side. And that's why you'll see a lot of pharmaceutical companies that tackle mitochondrial diseases look in that direction of changing the mitochondrial DNA. Things that hit mitochondrial DNA are things like oxidative stress and free radical oxygen. And so these are things we need to also remember.
Well, and in fact, the mitochondria as a powerhouse has some components like most powerhouses. Your car, not your Tesla, but your car going down the street's got the exhaust. Your power plant has a smokestack. With mitochondria, it's these reactive oxygen species. They're thought to cause oxidative stress. Are all reactive oxygen species bad?
No, I think it's in the field of mitochondria, there's this concept of mitohormesis, or in general in the cellular health field, is this concept of hormesis, which means you can go too less or too much, right? So the ROS, or reactive oxygen species, these are highly, these are oxygen-based radicals that if you accumulate too much and with chronic stress or chronic disorders that it's seen, you will shift the balance to a more disease phenotype. Now, a little bit of stress is good for the cells, and that's, so that in answer to your question, not all ROS is bad. A little transient activation does provide cells the signal to clean the waste, to kind of to optimize their health. But too much ROS over time accumulates that can be cleaned out or can shift the balance towards disease pathophysiology.
Mitochondria, like everything in our body, has a life cycle. What can go wrong with the mitochondrial life cycle?
Sure. So let's break down the mitochondrial life cycle for you and for your audience. So in essence, and a lot of it makes sense because in the field of mitochondrial health, there are nutrients that hit all different. So there are three main pathways, okay? One is this life cycle, what we call mitochondrial biogenesis, which really means newer healthy mitochondria are coming in. And so when you exercise, that triggers mitochondrial biogenesis. When you fast, that also triggers mitochondrial biogenesis. And then there's a second phase of what we call as optimization with fission and fusion. And this is where a lot of mitochondria are talking to each other, and the network of mitochondria that is inside a cell is very essential. And then the third part of that life cycle of a mitochondria is what is called cleaning or mitophagy. So mitophagy phagos meaning eating of the so in a cell, there's a very well dynamic between healthy and unhealthy mitochondria, and that is happening all our life, every time in our cells. But as we all age, this shifts towards more where we have accumulated a lot of dysfunctional mitochondria in our cell. And so that's what we want to focus on, as well as activating mitophagy. So these are the three key elements of a mitochondrial life cycle: biogenesis, sort of the fission, fusion, and the mitophagy.
Is there anything that triggers mitophagy, right? Like, what is the natural trigger of mitophagy, and where does it fail? And I'm assuming it's, typically with old age, where does that kind of fail so you end up not getting the mitophagy that you need? Yeah,
so mitophagy, as I started to describe, is like your garbage disposal mechanism, right? Think of it, of your garbage bin in your house, that if you're cleaning it out, your kitchen is smelling okay and nice, but if you just leave your waste for a week in your garbage bin, your kitchen and house will not smell well. That's exactly what happens at a cellular level, right? With aging, after, let's say, your 60s, a lot of these dysfunctional, unhealthy mitochondria, they put out an eat me signal, but they can be cleaned out because just the disposal garbage truck doesn't show up with aging as much as it does in our 30s and 20s and 40s, etc. Exercise and intermittent fasting, as I mentioned, for biogenesis, they also stimulate mitophagy. This is well known. Caloric restriction, typically 20% reduction in calories, is well known in different species to trigger mitophagy. Different forms of exercise regimens, aerobic and resistance, are known to stimulate mitophagy. And then, I've spent a good part of the last 10 years discovering molecules, natural molecules that also activate this pathway and can then trigger a better mitochondrial health. such as Urolithin A, which we will talk about.
So, in fact, you actually have multiple worldwide patents, like in Europe, Japan, the U.S., addressing mitophagy. When did mitophagy first come onto your radar?
It was about 10 years back, Chris. We actually started out looking at, we wanted to establish the biotech approach to nutrition, because a lot of times in nutrition, it's about blending multivitamins and minerals or plant extracts. And so we started with this philosophy of looking deeply into fruits and for example, nuts that had these really like, functional food status or like a food that we knew was associated with good health benefits. And so we started looking at it. And the pomegranate was one of the first we started looking at. Pomegranate has hundreds and thousands of bioactive compounds. And the one molecule that would always show up is not the polyphenols, not the antioxidants that are present in the pomegranate, but it's actually the gut microbiome transforming these polyphenols into the postbiotic urolithin A. So we were doing these experiments where initially urolithin A, for example, was thought as a waste product of this gut metabolism of polyphenols. So we were looking at these polyphenols that are called as punicollagens, and we found they weren't really having a big impact on health span and lifespan of different species, but this gut metabolite was having a big. And then we started digging in, and we looked at how it was doing it in mitochondria. It emerged very fast as the target of these natural compound. And then when we looked at it, it was mostly through the accelerating this mitophagy process, which is, as I mentioned, the garbage disposal pathway. And so if you gave it to old mice during aging process, you would see activation of mitophagy, cleaning of the waste, and then you would see more healthier mitochondria coming in. And so we found that all these rodents, older rodents, for example, were running and highly endurant by 40%. And so that led us to the whole journey of mitophagy activation.
How do you identify mitophagy as either failing and or working well? Like, so when you're trying something like giving the test subjects new materials, what is it that you're looking for? How do you identify that?
Yeah, so we use a lot of technologies that look at the genome level, and then we look at plasma biomarkers of a better mitochondrial health signature. So what we do typically is, when we first started out, we asked, how's mitophagy impacted during aging? So we took 70-year-olds who were running or training for half marathons, and we compared them to 70-year-olds, same age match, same genders, same sort of even ethnicity. And the only difference was they were one group was moving a lot and one group was much like very sedentary lifestyle. And then we took we can take small specimens from their leg muscles through a procedure which is a bit invasive. It's called muscle biopsies. And we can look at what genes are moving or not moving in the active versus sedentary old folks. And this is an unbiased way. So you have 30,000 genes in the human muscle, and you ask what is up and what is down. And all the first 30 genes that were up in those who were exercising all their life were mitochondrial genes, and those who were sitting around not moving much the mitochondrial genes were downregulated, including mitophagy genes. And so that was the aha moment where we said, okay, now we move to muscle, where we can probably trigger mitophagy and have an impact on muscle health and longevity with these kind of natural molecules such as urolithin A.
And to go back to really kind of identifying urolithin A as a really good subject, you're initially looking at pomegranates, you're looking at components of pomegranates. Are you introducing those in a petri dish? Are you introducing those maybe directly into the bloodstream, so you're bypassing the process where they would generate urolithin A?
Yeah, so the initial work was done, a lot of longevity studies. The initial work is done in worms. These are called C. elegans, because they live about 20, 30 days, and you can very fast assess which compounds are having an impact on longevity pathways or not. And then you move to rodent experiments where you take older rodents and for example, their mitochondria or their muscle cells, and then you see the impact, and then you go to the human. So we have done all that over the last 10 years. We've gone from starting out and comparing Urolithin A, for example, to other longevity compounds like rapamycin or metformin, for example, doing head-to-head or even caloric restriction. And one of so we are based out of the Swiss Institute of Technology, and one of the professors we work is really a mitochondrial guru. We gave him this compound, and he came running to our office and saying, "What did you give it to me? I mean, this compound, this is boosting the lifespan of worms by like 45%, which is only previously known with caloric restriction." So that's what actually made us sit and notice that a lot of these scientists are figuring it out. And so we went to rodent models, and since then we've run almost at least 6 randomized trials in different populations: older people, overweight people, and even elite runners now.
What were the results in rats or mice in terms of longevity?
Yeah, so in the rodents, we gave 6 to 8 weeks of supplementation in the diet, and no exercise, no change in diet of these rodents, and these are about 20-month-old rodents, which is equivalent to an 80-year-old human being. We saw about 10% improvement in muscle strength. We saw about a 50% increase in muscle endurance. We saw lower inflammation in these mice as well. And then we also did it in combination with exercise, and we saw these even an additive effect over exercise. So if you combine exercise with a mitophagy activator, you get even a better effect. In terms of longevity, most of these mice, we haven't looked at it, but we do know that there are groups out there who are about to publish that they see similar increases in lifespan that are attributed to other well-known longevity compounds.
And one of the best kind of contributors to lifespan, and it's certainly well documented, is caloric restriction. And in C. elegans, caloric restriction kind of similar, 45%.
Yeah, I think caloric restriction is the holy grail. It's about 50% improvement in lifespan. I think compounds like resveratrol, for example, which has been studied a lot, and NAD modulators do it by 20-25%. Rapamycin in the same zone. Metformin increases lifespan by about 40%. That's why a lot of clinicians now like to trial metformin in longevity trials. Urolithin A is about 44-45%. So that's what got us excited initially, that this was very close to almost like a caloric restriction in a pill.
Hey, super quick break from the podcast. Hopefully you're loving it. This is a way you can support the podcast and take advantage of a great offer. We're offering 50% off of one of our MCT bottles. MCT is an amazing oil. Add the ESS60 molecule to it. It's even more amazing. All you got to do is leave a review on iTunes, send us a notification that you've left that review. We'll get you a coupon code that'll get you 50% off of our MCT oil and free shipping. Back to the podcast.
Yeah, and that caloric restriction is about you said 20. I was always familiar with the number 30% reduction in currently consumed calories. I always described that as the starve yourself 1/3 to death diet, which no one really likes to sign up for that diet. I don't know if they need a new marketing angle or what it is that they need to do, right? But it's not a popular strategy.
Yeah, compliance would be a big issue. I mean, people have done 30%, 20%, even 15%, but I think compliance would be a huge issue with the more stricter you become.
Yeah, I think in Dr. David Sinclair's book, Lifespan, he just describes it as frail people wearing sweaters all the time. So in one of your studies, you took sedentary and frail subjects, and within 4 weeks of supplementation with Urolithin A, they showed mitochondrial hallmarks similar to the cohort that runs full and half marathons. And you may have talked about this a little bit. This is great for the sedentary folks, of course. And I think you mentioned this, but maybe go a little bit deeper. Talk to me about the possibility of compounding the results. So you're already training, and then you're adding Urolithin A to your training regime or to your supplementation while you're training.
Yeah, so I'm a trialist, and as a trialist, you always select the population that has the biggest chance to succeed in a trial, right? So we started, of course, with the older adults who weren't moving around, and we, as I mentioned before, we had seen that their muscles had poor mitochondria. And so, as you mentioned, we supplemented them for 4 weeks. and we could see the same mitochondrial health biomarkers go up that we were seeing in comparison with those who had been, exercising regularly all their life in their adult life. And so that led us to doing much longer trials where we started teasing out the muscle performance effects specific. So we went into, again, slightly younger 40, 50-year-olds because, well, in older adults, we know these longevity pathways, these mitophagy pathways are being shut down. We went in and looked at 40, 50-year-olds who are not, let's say, athletic, but they are moving around and they're doing their daily activities of living. And yet again, in the absence of no change in diet or let's say physical activity levels, we saw about a 10% improvement in their muscle leg strength. And we've done more trials again, and even in the older adults who are physically active, and we show improvements in endurance. The trial that is not yet published that we just completed that answers probably your question the best is we went after elite Olympian level middle distance runners who before a competitive season they go for a month-long high altitude training, and they do uphill, downhill running, and they adapt and they get better with the competitive season. And so we added MitoPure, of course, in comparison to a placebo, and we asked the question, will these athletic individuals have better recovery and less inflammation? And the answer is yes. So we see about a twofold better recovery in these, and these are all young, late 20, early 30 competitive runners. And the other fact we see is that the athletes actually they overtrain sometimes, and that has a detrimental effect on their mitochondria as well, and they're inflamed. So actually, it makes a lot of sense to give Urolithin A or MitoPure to these kind of populations. Our consumers actually, I would have thought as a doctor that a lot of older people, of course, would take it, but I see a lot of young 40, 50-year-olds taking a product who are, trying to keep their physical fitness levels up there when they were in their 30s or 40s. So I think it works very nicely with physical activity, exercise.
Did you look in C. elegans in dosing lower? Did you tend to start dosing when they were older in age? Or did you kind of run both, and do you see similar results across both age, when you start dosing them?
So you definitely see a dose response in different species. You have a sweet spot, even in humans. So when we did our first human study, we tried 4 different doses from 250 milligram. We increased it to 500 to a gram. The sweet spot of the dosing is around 500 milligram to a gram. So that's where we see the best effects on mitochondria and inflammation. 250, I think if you go lower, you probably just need longer worth of time to really look at the effect. We haven't just done that yet in terms of looking at longer trials of 6 months and beyond with lower doses.
Have you looked at any kind of prebiotics that might increase urolithin A?
We have studied. So I did a trial where I gave in US where I took 100 people and I gave them a glass of pomegranate juice, which was 100% juice. So theoretically, that had all the dietary precursors. And I asked the question, how many would convert? The answer was about 40% did convert, albeit in different levels. The remaining refused to convert. And so actually that led me to another idea where I have now developed even a test that is still in prototype, but you can actually test and learn yourself if your body can naturally make this molecule, because a lot of us think we are eating right and if you're taking the right prebiotics. So we looked at the gut microbiome of the people who naturally make it and those who don't. And it turns out that people who make it, as I call them, the blessed people, they have a very rich and diverse gut microbiome. So obviously, if you modulate your gut microbiome by eating a lot of fermented foods and prebiotics and the right probiotics, you probably have a good chance to making the molecule naturally. And of course, you need to eat right? So you need to eat your bowl of berries, nuts, and pomegranate probably every day.
Have you looked at, how antibiotics might destroy the process of making urolithin A?
I'm a personal example of this. I grew up in India, and if you have grown up in India, for anything from a common cold to a upset tummy, you get antibiotics, and your gut microbiome just never can be reset, in my opinion. And so I think I eat right today, but I can drink 6 glasses of pomegranate juice, and my body just refuses to make urolithin A. And I've developed the test. I've tested myself almost 50 times. Just there's no urolithin A unless I supplement myself. So I think antibiotics are big stressors, not just for mitochondria, but your gut microbiome, and that kind of that double whammy just knocks off your capacity to make urolithin A. You can probably there are academic folks I know who are studying if they can actually transplant the gut microbiome of mice that can produce urolithin A into mice that don't produce, and if that can be done. So in the future, maybe somebody will discover a probiotic or a right blend of prebiotics that can be used to naturally boost urolithin A levels.
Maybe we can all get the blessed microbiome necessary.
Well, we have studied it very deeply. I've spent 5 years of my life trying to figure out if there's one probiotic or one strain that is important. I don't think the answer is. I think the gut microbiome is such a complex ecosystem that you need to have a perfect harmony. And we do see things like Akkermansia, for example. We see it up in people who are very high producers of urolithin A. Now, is that mean that Akkermansia is involved in sort of the natural biology of producing urolithin A? I don't have an answer to that. I just think that is an indicator your gut microbiome is in a good state.
Okay, so at this point, you just a diverse microbiome is typical of somebody who can produce lots of urolithin A, but you haven't identified like which particular gut bacteria it is that's actually producing urolithin A.
Yeah, and we struggle to find it, and that's why we decided that the easier strategy, even if you figure it out with the bias of diet, how everybody is eating different, and the bias of the production, it's not a one-to-one that one molecule of the precursor will become one molecule. We felt the right approach to give, let's say, a consistent benefit would be direct calibrated supplementation, which is why we went in and we developed these nutritional supplements with a very targeted approach of direct dosing of urolithin A.
And you work with more than just urolithin A, or I think you have some face products. Is that correct?
Yeah. So a lot of research was on muscle, and then when we launched our products, a lot of people loved it and still loving it. The first question I would get is, well, doc, how do I measure my mitochondrial aging, and how do I see the effects when I wake up? And I thought to myself, well, it's usually at the end of the day when you had a rough day that you feel that you still have energy to play with your kids or go around, make your 5K run at the end of the day. That's usually how if you have more energy left in the tank. But to see it on a daily visual level, well, everybody wakes up and looks at their face, and you see the effects of Father Time there. And so that led us to developing topical formulations that we then combined with the sort of other strategies to boost mitochondrial health, such as adding niacinamide, which is a NAD booster as well. And so together, these products we found in addition that where urolithin A did a great job was in skin, you have two kinds of aging. You have intrinsic aging, which is basically your mitochondrial cellular aging, and then you have extrinsic aging because of all the pollution and the harmful UV rays. Your skin is tending to age much faster than your internal organs. And so we looked at different trials, and we found an effect not only on rejuvenating the mitochondria in the skin cells, but also by inhibiting this sort of inflammatory cascade that pollutants, skin irritants, or UV damage has on skin aging. And so, yeah, that's why we have these skincare health products now.
Have you looked at C-reactive protein as I believe that's an indication of inflammation and with after urolithin A administration?
In every trial, I mentioned at the start, I'm an immunologist, and so One of the easier ways to look at inflammation, as you rightly point out, is C-reactive protein. So we've looked at CRP in all the older adult trials, and we see a significant reduction starting already at 2 months of supplementation. We've also looked at overweight adults who are probably on this accelerated aging pathway, and their bodies are already inflamed because they have excess fat mass. And there we see an impact on lowering CRP. Even athletes after exercise training, their CRP goes up, and we see. So now we have done almost 3 trials with 300 participants, and we see a very global impact on CRP. And that tells me that, again, back to what I started saying, is that there's a very deep connection between your mitochondrial health and your sort of immune and inflammatory status.
You said that customers are asking like how to kind of address the effectiveness. Have you looked into DNA methylation, age tests? And there's one, I think I've got an interview later, DNAge, my DNAge, and then also glycanage. Have you looked into those two?
We've looked into all kinds of these aging clocks. The problem is there's so many of these aging clocks out there. And so actually one of our advisors is the CEO of the Buck Institute of Aging. He has looked at all the aging clocks, and they all give different results. And so we are now actually we're working with one of the top gurus to really pick the right aging clock. And we're working with a company called True Diagnostic, which actually looks at holistically at all kinds of aging rates on your immune cells and your methylation patterns, and then gives you a combined score. So yeah, stay tuned. We'll have some really cool information to share there.
I think glycanage might be interesting because they're the ultimate hallmark that they're looking at is inflammation, and that seems to be the easiest thing that you're addressing.
I agree. I have spoken to the CEO there, and I think they're onto something as well. I think glycanage looks at the glycation patterns in your immune cells, and that makes it very relevant.
Also, I took that test, and it says I'm 33 years younger than my chronological age, so I kind of like it.
You like it there. Well, I like True Diagnostic as well because I took MitoPure supplementation, and I'm 45, and after 1 month, I reduced it by 8 years. So yeah, I think you have to try. It's really, that's why we call it research. It's 2 words, re and search. You have to keep experimenting to find what is the right tool that everybody can then take to analyze mitochondrial health or biological age.
Dr. Singh, this has been fascinating. I've got a couple wrap-up questions.
Sure.
So do you have a target age that you want to live to?
I'm more in the longevity space now. You have 2 camps. One that, of course, wants to live longer beyond 100, 120, 150 is talked about. And then there's the camp of health span, which I firmly believe if I live till 80 or 90 or 100, if I'm blessed to live that long, I want to be active. I want to be going about, doing my daily activities of living and being able to think clearly and playing with my grandkids. And so for me, it would be if I'll take 80, but 80 as an active 80-year-old. That would be my answer.
So it could be adjusted as long as you have what I describe as same mental capacity and the same physical capacity that you have today. Yeah, I think ultimately even the people who I think Dave Asprey says 180. I think his it is contingent on being mentally and physically adept, right?
Exactly.
Do you think there is a cutoff, like how long can humans live?
If you study all these big longevity studies, and of course there's these blue zones that everybody likes to talk about, and there's really 3 pillars behind it. It's very simple. It's keeping physically active. It's keeping your diet, fresh from the farm. And then, what in addition, what's your support structure? How much stress do you have? I think the sweet spot is around 120 from what I think. And I think we can live that long healthy. Now, beyond those, then we have to consider, as you were talking about, what's the mental capacity and the physical capacity beyond that we can extend.
From you, I was hoping to get 2 or 3 protocols, habits, mindsets, let's call them shortcuts, because everybody likes shortcuts, for longevity and health span.
Great. Well, my shortcuts I firmly believe there's 3 pillars of good health. One is what you eat, right? And how much you eat. And I do practice intermittent fasting myself. So I eat only between in 8 hours of lunch and dinner. I don't have breakfast, for example, and I fast for 16 hours. And that, since I've started it, I do feel, the clarity and more energy. The second is exercise. Now I don't train for marathons, but I do I'm what we call a weekend warrior. I do make time every now and then to certainly get my 8,000 or 10,000 plus steps in a day. So, that's the second pillar of physical activity. And third is really what, in addition, you can add to strengthen these 2 pillars. And that's where I think a lot of nutritional strategies come in place. And one of the ones we talk about is Urolithin A, but there are other strategies, linked to better mitochondrial health or better cellular health. And of course, the fourth one would be, have a good stress-free structure around you, sleep better, and have good support network. And I think those 4 or 5 fundamental things is what I aim for to really keep my cellular health at its peak.
I think that's awesome. Dr. Singh, how can people contact you?
Sure. So folks can look up our work and our products and our website. For sure, it's timelinenutrition.com. If they want to read more about the work I've been doing around the discovery, they can go to mitopure.com, which is basically a patented form of Urolithin A. And if they want to send questions directly to me, then, they can shoot me an email at asing@amazentis.com.
Excellent. And what in the near future are you excited about?
I'm super excited about a study we're actually running to tackle immune aging, and hopefully in 3 to 6 months, maybe we touch base again. And so this study is really looking at how we can rewire the immune system as we age and make it youthful. And the second immune study we're looking is actually in cancer survivors that have beaten cancer, but the immune system has emerged out of it less potent, and how we can rewire that immune system following a big stressful stressor like cancer. And so, immune aging, I think, is where a lot of my excitement rests right now.
All right. You can find Dr. Singh at timelinenutrition.com and his work there, and at mitopure.com. Dr. Singh, thank you so much for joining us today.
Pleasure is mine, Chris. Thanks for having me.
I hope you enjoyed this episode of the Live Beyond the Norms podcast. Make sure to subscribe and follow. Also, make sure not to be that guy, the guy sharing this podcast with people who are not interested in living beyond the norms. If you would like to learn more about the ESS60 molecule, the molecule responsible for the single longest longevity experimental result on mammals in history, a full 90% extension of life, visit myvitalc.com. That's myvitalc as in carbon.com.